Hello, welcome back to Mrs. Torres' YouTube channel. Today we are going to be simplifying square roots. Another name for that square root symbol is a radical. So let's look at an example. First we are just going to simplify some individual square roots and then we'll add some more to it. So when we simplify square roots, we need to find the prime factorization of it. To do that, we are going to make a factor tree. So we're looking for two numbers that multiply to 252. If you don't know any off the top of your head, just do in your calculator 252 divided by 2. Do you get a whole number? 252 divided by 3. Do you get a whole number? And so on. So I know that 4 times 63 gives me 252. Now when we're doing this factor tree, we're looking for just prime numbers. That's when we can stop and circle our number. So 4 is not a prime number. We can split that up into 2 and 2. 2 is prime, so I'm going to circle those. 63 we can split up into 7 and 9. 7 is also a prime number, so I'm going to circle that. And 9 we can split up into 3 and 3, which are also prime numbers. Now, once we have that, I like to rewrite all my prime factors. So 2 times 2 times 3 times 3 times 7. You don't have to do this step, but I just like to, so it keeps my work a little more organized. Once we do that, we are looking for pairs of numbers. So we have a pair of 2's and a pair of 3's. If you have a pair of numbers on the inside of our square root, because this is really the square root of 252, that becomes one of those numbers on the outside. So this 2 becomes a 2 on the outside. This 3 becomes a 3 on the outside, and we multiply those. 7 doesn't have a pair, so it stays under the square root. So really, it's 6 root 7. Now, if you don't like that way, there is another way to do it. There's nothing wrong with this way. If this way makes sense to you, you don't have to worry about another way. But there is another way we could do it. We could look for perfect squares that divide into the square root of 252. So over here we had 4 and 63. 4 is a perfect square, right? So we could rewrite the square root of 252 as the square root of 4 and the square root of 63. Once we have a perfect square, we're just going to leave it. So how can we split up 63? Well, we know 9 and 7, right? So square root of 4 times the square root of 9 times the square root of 7. Once we have all perfect squares or prime numbers, we can stop. So perfect square, prime. And then we just find the square roots. So the square root of 4 is 2. The square root of 9 is 3. And the square root of 7 we can't do anything with. Well, look at that. We got the same answer, right? 6 root 7. So whichever way you prefer, fine by me. All right, let's do another simple one. It just has a little wrinkle in it. So simplify 2 root 27. The only difference here is we have this 2 out front. So at the very end, we're just going to multiply by 2. So let's simplify 27, 3 times 3 times 3. So this simplifies to 3 root 3, right? Because we have a pair of 3's there. However, we can't forget about this 2, so we've got to bring this 2 down on the outside. So this simplifies to 6 root 3. All right. That should have been somewhat review from Algebra 1 and Geometry. Now let's add some Algebra 2 in there. Let's try this one. 7 root 6 minus the square root of 54. We're going to use all these skills that we know up here, except we're now adding and subtracting. So the first step does not change. We're going to simplify our square roots. So the square root of 6. Can we simplify that? We cannot, because if we would do our factor tree, it'd be 3 times 2, there'd be no pairs. So 7 root 6, I'm just going to leave that as it is. Minus the square root of 54. We can simplify that. I like the factor tree method, so I'm going to use that, but if you like this way, do it this way and make sure you get the same answer that I get. So 54 is 2 and 27. 27 is 3, 3, and 3. So I have a pair of 3's and then 2 times 3 on the inside. So 3 root 6. So that's nothing new. Now, notice how we have 7 times the square root of 6 and 3 times the square root of 6. So what's under the roots are the same exact thing. We can treat these like pairs, or like terms, and we can combine them. So what I mean is, if I would replace these square root of 6's with a variable, so if I had 7x minus 3x, we all know that is 4x, right? We can apply that same logic here. 7 times the square root of 6 minus 3 times the square root of 6 is going to give us 4 root 6. It's just like combining like terms. All right, let's try another one. 2 root 5 minus 2 root 6 plus 2 root 24. So first thing we're going to do, simplify our square roots. We can't do anything with square root of 5, so we're just going to bring it down. We can't do anything with square root of 6, so we're also just going to bring that down. We need to simplify 24. We can do that. So 2, 12, 2, 6, 2, 3. Pair of 2's. Now be careful. This is 2 root 6, right? But don't forget we have a 2 out front here. So I'm just going to write 2 times the square root of 24, which is 2 root 6. So the square root of 24 is just 2 root 6. Now we can multiply these. Again, if we kind of think of this as a variable, if I had 2 times 2x, that would just give us 4x, right? Well, same logic. Let me rewrite 2 root 5 minus 2 root 6 plus 4 root 6. We just multiplied those. Now that everything is simplified, everything is multiplied, let's combine like terms. Now, we have to be very careful here. We have square roots of 5 and square roots of 6. So we only have some like terms, right? If we thought of our square root of 6's as x's, this would be like a y, right? So we would have something like 2y minus 2x plus 4x. We can only combine like terms. So here we can only combine these. We have nothing to combine the 2 root 5 with. And then negative 2 plus 4 gives us positive 2. So that would be our final answer. So you're not always going to be able to simplify it to one term. Sometimes you'll have 2 terms, 3 terms even, 4 terms sometimes. All right. Go ahead and pause the video after I've done writing this and try this one on your own. And then come back and we can compare answers. So we have the square root of 18 plus 2 root 54 plus 2 root 2. So go ahead and pause it and try this one. All right, welcome back. So we need to simplify some square roots here. So the square root of 18, let's go ahead and simplify that. 2 and 9, 3 and 3. So this is 3 root 2 plus, I think we already simplified this up here, right? Square root of 54 simplifies to 3 root 6. So we have 2 times 3 root 6 plus 2 root 2. We can't really do anything there. So before we combine like terms, let's multiply these together. So 3 root 2 plus 6 root 6 plus 2 root 2. Now that we have everything simplified and multiplied, we just combine like terms. So we have a 3 root 2 and a 2 root 2. That gives us 5 root 2 plus 6 root 6. And that's our answer. All right, that's it for today. See you later.